Hey guys, Mr. McKinney here, just going over some AP questions that I modified to kind of match the applying definite integrals worksheet that you guys did at the start of this semester. All right, and this is a very common question on the AP exam where one function is defined as the definite integral of another function, and then they'll give you a graph of the function that you're taking the integral of. Now, the first thing you want to do is you want to think about, all right, if g of x is equal to the integral from 2 to x of f of t dt, then we need to figure out what g prime of x is the same as and what g double prime of x is the same as. This is the most important part on this type of problem. Now, if we take the derivative of the integral, so if we take the derivative with respect to x, going from 2 to x of f of t dt, this is the fundamental theorem of calculus. As long as these variables match and this variable matches, then you just plug in the x here, and g prime of x would be f of x. Basically, just the derivative and the integral undo each other. And then if we take the derivative again, the derivative of f is f prime of x. Now, for this particular problem, what that's going to mean is that g is an area on the graph because it's a definite integral. G prime is just f, so it's a point on this graph, and g double prime is f prime, so it's the slope of this graph. All right, so to find g of 0, I'm going to say, well, g of 0 is the integral from 2 to 0 of f of t dt. So we're looking between 0 and 2, what's the area of this triangle? So the area of this triangle would be 1/2 times 2 times 4, which is just 4. Now, if I did the integral from 0 to 2 of f of x dx or f of t dt, that would be a positive 4. Since I have the integral from 2 to 0, that's the same as switching the limits and putting a negative out front, which means that this first one is just going to be negative 4. So g of 0 would be negative 4. Area above the axis is positive as long as the lower limit is less than the upper limit. If they're backwards, then you got to flip it and put a negative out front. All right, so g prime of 0 is the same as f of 0, which is just the y value of this graph when x is 0. So it's that point right there. So it's 4, and I'm done. G double prime of 0 would mean what is f prime of 0? So what is the slope of f at this point up here? Since we're at a corner, this would be undefined. So I added this extra problem, find g double prime at 1. So g double prime at 1 would be the same as f prime at 1, which is the same as the slope of f when x is equal to 1. And if I look at the slope here, I'm going to do a slope calculation. So the 2 points that I'm going to use are 2, 0 and 0, 4. I'm going to use this point and this point and find the slope going through them. So y2 minus y1, 4 minus 0 over 0 minus 2 would be negative 2. So the slope of this graph is negative 2, which means that g double prime of 1 is negative 2. Okay, to answer whether g is increasing or decreasing, or if g is concave up or concave down, we want to think about the derivative of g or the second derivative of g, and then how those relate to f, and then look at the graph and answer it. So on what intervals of x is g increasing? So I'm going to switch colors so we can follow it a little better. So g is increasing when g prime is positive. In this case, g prime is positive when f is positive, because g prime and f are the same thing. So I'm just looking at when f is positive, when f is above the x-axis. So f is positive on the interval from -2 to 6, which means that g prime is positive on the interval from -2 to 6, which means that g is increasing on the interval from -2 to 6. On what intervals of x is g concave down? So g is concave down when g double prime is negative. G double prime is the same as f prime, so that's when f prime is negative. F prime means the slope of f, so when the slope of f is negative. The slope of f is negative here, the slope of f is negative here, and here. So we'd have 3 intervals. I'm going to switch colors so we don't confuse it with this -2 to 6. So our 3 intervals would be from 0 to 2, and from 4 to 8, and from 10 to 12. So whenever the slope of f is negative, that means that f prime is negative, which means that g double prime is negative, which means that g is concave down. The most important part on this type of problem is writing out these relationships at the start so that you can answer the questions accordingly. All right, next one. And this is another very common type of question on the AP exam. They're going to give you rates. This is the rate of customers removing bananas. And what I recommend is that you hit pause, read through this, attempt it on your own, then listen to me go through it. All right, so this is the rate at which they are being removed. So this is my remove rate. This is the rate at which they would be added by the employees. So this is the add rate. So we're removing bananas, and then starting at time equals 3, we're also adding bananas. And then these questions are going to ask based on one of these 2 things. So we've got these 4 parts, and I've broken them up on the next 2 slides. So the first thing you'd want to do on this type of problem is figure out what equations you should be doing, and then let your calculator do the work for you. When you see like sine of t cubed divided by 100 or ln of t squared plus 2t, this is going to be on the calculator portion of the AP exam. So again, this was the remove equation, and it's the rate, and this is the add rate. So these are both rates. Okay, so how many pounds of bananas are removed from the display during the first 2 hours the store is open? So how many is an amount? To get to an amount from a rate, we need to integrate. So to answer part A, we would do the integral of this rate, f of t dt. For the first 2 hours, means we're starting from hour 0 and we're going to hour 2. And then again, let your calculator do that for you. And I'll show you guys how to do it in the calculator in a second. But basically, you're just going to put this into y1, and then the calculator is going to do it for you. All right, find f prime of 7. So f prime of 7 means the derivative. And again, we're going to let our calculator do that for us. So f prime of 7, we're just going to do math 8 on the calculator in a second. The meaning of it, so since f is already a rate, f prime is a rate of a rate. So this is a rate of a rate. And once we get the answer here in a second, we'll explain what it means. All right. Part C is the number of bananas increasing or decreasing at time 5. So to figure out if the number is increasing or decreasing, we want to know if the rate is positive or negative. And basically, we're going to look at the difference between these 2 rates. Since they're already rates, I don't need to take the derivative. I'm going to be looking at f of 5, and I'm going to compare it to g of 5. So this is the rate being removed. This is the rate being added. If the rate added is more than the rate removed, then the number of bananas is increasing. If the rate removed is greater than the rate added, then the number is decreasing. And once we punch buttons on the calculator, we'll be able to answer that. And then the last one, how many bananas or how many pounds of bananas are on the display table at time t equals 8? And there's one piece of information we have to go back to the original problem. We started with 50 pounds of bananas. So to figure out how many bananas are there at t equals 8, we're going to say how many did we start with minus how many did we remove plus how many did we add. So we started with 50. To figure out how many removed, we have to use the integral of this rate. So we're going to subtract the integral from 0 to 8 of f of t dt. And then we're going to add however many got added. Now remember that they didn't start adding until 3 o'clock. So instead of going 0 to 8, this one's going to go 3 to 8. And again, we're going to let our calculator do all this work for us. So now that we've got it worked out, we're going to go back and then let the calculator give us some answers. So I've already got everything typed in. The first thing you would need to do is go to y equals, type your two equations in. So this is my f equation, this is my g equation. Now, the first problem, part A, you wanted to do the integral from 0 to 2. So we get 20.051. So this answer was 20.051 pounds of bananas were removed during the first 2 hours. So just put this equation into y1 and then just math 9 and let the calculator do it for you. Now to find f prime, you're going to use math 8. So that's what I did here. Math 8, we're still doing it for y1 at x equals 7. So I get negative 8.1195. That's going to round to, hold on, where my pen go? Okay, so that's going to round to negative 8.120. It's a rate of a rate. So this would be pounds per hour per hour. Now the main thing to keep in mind is that if we're talking about a rate of a rate, we're either talking about how the rate is increasing or how the rate is decreasing. So we would say that the rate is decreasing since the rate is negative. And we would say that the rate at which bananas are removed is decreasing. You would get 1 point for the value and then 1 point for making sure you specify it correctly. So you could say the rate of the rate is this, or you can say the rate is decreasing at this value. All right. Is the number of pounds increasing or decreasing? So going back to the calculator, I'm going to look at f of 5 and I'm going to look at g of 5. When I subtracted them, I got a positive value. So that meant that f of 5 was greater than g of 5. So the rate remove was greater than the rate being added. And if the rate being removed is greater than the rate adding, then the number of pounds is decreasing. And the reason would be these values. You would write down the values and say the rate removed is greater than the rate added. Last one, how many pounds? And again, you're just going to do this all in the calculator. And so I've got that here. You would do 50, take away the ones that were removed, and add the ones that the store clerks added. And then when you hit enter, you're going to get 23.347. So 23.347 pounds of bananas on display at t equals 8. All right, take a look at this last problem. I'm running out of time, so I'll record this in a separate video, but it'll be pretty quick, so the second video will be short. Hope this was helpful.